All right, you're probably gonna get feedback because I am now streaming. So I'm going to mute on Zoom, and then you can find the instruction on Twitch. You can either use whatever device you're working with right now, or you can use your phone. All right, Saintsmen, greetings. This is our first lesson for geometry for section 1.1, which is points, lines, and planes. We're going to go over a few basic concepts for you guys to get started within the course. This course is what is called a Euclidean geometry course. We are going to do a steady examination of what is called Euclidean geometry versus non-Euclidean geometry. Non-Euclidean geometry may come up at the end of the course. It's going to blow your mind the day that it does. Euclidean geometry is based off of a branch of geometry that originates with an ancient Greek philosopher by the name of Euclid. Euclid is from about the 4th century BC. He was not a contemporary of Plato. In other words, Plato and him did not live at the same time, but Euclid lived shortly after. He was influenced by Plato's work. The interesting thing is, for us being an Augustinian institution, the Augustinian tradition tends to have a lot of Platonic connections. So Euclid's Elements is the book that most of this is based off of, and it's a beautiful piece of work. It's an important book in history, and one of the reasons it's loved by philosophers. In fact, when I took philosophy as a freshman in college, the first text that they handed out to us was a copy of Euclid's Elements, and it's beautiful and elegant in the way that he approaches defining a system of knowledge. And he starts with a basic idea, and he builds it out from there. And it's a system of principles and postulates is what the word that winds up being used. Postulates and axioms. It just depends on the translation. So what's great about that, for example, is that you're going to find that this course is one of the most important that you're going to encounter in high school. I think many teachers feel that way. I can tell you that some of the things that we're going to do in this course, you're never going to use strictly again. I mean, we're going to discuss two-column proofs in the next chapter, and you will likely never do a two-column proof after this course. But the thinking that's involved has never been more important. To understand how to create a logical argument based upon some sort of system of knowledge or facts is exceptionally important. So what we're going to wind up starting with is the very basis of geometry, which is, oops, sorry, you can tell my daughter was using my tablet. I was writing in a rainbow pen. And we're going to discuss the point. So what a point is. A point was the most difficult thing when I was a high school geometry student, and it's the very first concept for us to discuss. And it was the most difficult for me to accept, and that I wound up kind of rejecting the idea of it for some time. And I would argue with my high school geometry teacher about this because it's incredibly difficult to say what exactly a point is. A point is a place or a location, and it has absolutely no shape or size. Which has to sound strange, right? No shape or size. Mathematically, when we see it, you guys, you create it and it looks like that right there. Some students have said, oh yeah, that's just a dot. I want you to get away from that. I think that Google as a company has done a good job with identifying points on maps because they refer to them as pins because it has this infinitesimally small sort of idea that's behind it, and I want you guys to embrace that. It's a really tiny thing, and but also not, because if something is tiny, then it means that it has some sort of shape and size. Okay, I think some students also refer to it as a location. I've heard that used before, and I think that's another great way to consider it. Because when we start thinking about where is Phoenix, Arizona, right? And we're looking at a map, we can place a dot to represent Phoenix, but we're trying to really just represent some sort of place or location and not necessarily what the outline of the metropolitan area is. So I want us to divorce ourselves from thinking that some sort of a point has any size and shape. Going back to Euclid and his philosophical predecessor, Plato. Plato had a book called the Republic, and in the Republic, there's famously what's called the allegory of the cave, and in that, the idea and thought experiment being that if you have a person, you deprive them of sense, so you put them in a cave. You have a man. He's born, but he's never been able to experience sight, and just kind of has his senses shut off. But what would he? It's the idea that some of you have heard in your religion classes of a priori versus a posteriori knowledge. So is knowledge innate? What would, if you were to deprive a man of sense from birth? What would he emerge from the cave knowing? It's a good thought experiment. It's an important one, and the reason I bring this up is because one of Plato's contentions, and let's think about a triangle, which you're all familiar with mathematically, is that a triangle can't exist. Plato's contention: a triangle can't exist perfectly. Like you cannot draw a triangle. Right now, I could draw. There's trying to think into shape, right? So I can go and boom, here's a triangle, and then the software fixes it for me, but I can't draw a perfect triangle. It's impossible, right? Because there's going to be some sort of flaw to the screen, to the software, to whatever. Even if you were to try to draw one with a pencil and paper, you're not going to be able to do that appropriately. The only place that it can really exist perfectly is in your mind. So there's not a physical manifestation of that triangle that's going to be perfect. We can represent what that would be. I can say draw a triangle, and you have an image in your mind, and that is a perfect triangle. I want you guys to be there with point and line as well, where a point is something specific. It's a specific spot. Because we have nothing better to work with, we use a dot, right? We use a tiny little speck. On the whiteboard or on a piece of paper. Next, we have the line. And a line, by definition, is made up of points, and it's an infinite number of points. Usually right here I get, oh, it's made up of 2 points, but that's not true. We can give it constraint by 2 points and terminate the line. And there is, because a line is made up of points, logically speaking, then a line, since a point has no shape or size, then a line being made up of points would have no thickness or width. So let's move to how we'll see these things. So a line, typically we're going to see represented a few ways. You can have what's called line L. You can name the line by a single lowercase cursive letter. Versus a point, we can identify by a single uppercase letter. So if I'm going to put some points on the line to define it, I'm going to put points A and B on that line. And therefore, now I can actually name this thing a couple different things. For example, I can refer to this as line L. I could also call this line AB. Or also, it doesn't have to be in alphabetical order. It could be line BA. Line AB and line BA are the same thing. The same way that you as a person, I could call different names, right? There's some sort of a nickname. Appropriately, we can, there's no order for these things. It's arbitrary what's going to come first or what's going to come second. It's not left to right. It's not alphabetical. It's just however you decide to identify it. And mathematicians over time have come to this agreement for these things. Also, you'll see this. Oops, I'm having a lot of issues with my stylus today. AB, and you'll see a little line over the top of it. Or also BA with a little line over the top of it. Same thing. Okay? Little thing is that there is exactly one line through 2 points. Okay, so that's just one of these things that we're gonna postulate that Euclid does within Elements. He goes fact by fact. It's really beautiful how he builds this system of geometry. Abraham Lincoln, former president, the 16th president of the United States, who was a brilliant scholar, passed the bar exam without attending law school. He just got some books and taught himself law. He was said to have memorized a good portion of Euclid's Elements and supposedly carried around a copy of it with himself. Because, again, it should make sense, a lawyer understanding laws and how they affect each other and laws and rights and so forth. Same idea with geometry, that there's this system that we're building of knowledge and how all these concepts affect each other. Line L or line BA is the same exact line, right? It's the same line. It doesn't matter how I twist or turn it. That line, those two locations, only one line is going to go through it, not a differently defined line. I think you have to think of oneself, right? Like you are the unique instance of yourself on planet Earth. So, I can call you different things, but you are you, and that is exclusive to your being. Throw out a couple other things here. We're going to actually now discuss the plane. Okay, and the plane. So thinking about how a line, right? Like you could take your pencil and that's in your hand, that taking notes, and think about if you were to extend in both directions infinitely, right? That's what these arrows mean. For the record, there's some other constraints we can give. We can make it a segment and actually terminate the line and calling it a line segment, and we'll go over that shortly. But a plane. So imagine a sheet of paper, like the sheet of paper you're writing on, extending in every direction. Up, down, diagonally, left and right, infinitely. So that's something for us to consider. So it extends infinitely in all directions. Looks like my stylus is a little busted right now, so I'm going to have to start writing things out. Okay. It's I think it's one of the things that we think about with a plane is that it is flat. In Euclidean geometry, that is. Okay, so one plane is that there are an infinite number of lines. And if there's an infinite number of lines, that would also mean that there are an infinite number of points within it. Also, there are a minimum of 3 non-collinear points in a plane. And I think there's a word that just came up, or a term that came up, that is probably a little bit confusing, and you guys just saw a word that says collinear or non-collinear, okay? So there's 2 terms I want us to discuss here. One is collinear. Co, like con in Spanish, means with, okay? So it means that it is with the same line or shares a line. So the 3 non-collinear points, I want you to think about in a plane putting 3 points, 3 dots there on your paper, right? But make sure that they're not in the same line. Because in a line, you can extend an infinite number, right? You could just think about a pencil. How many sheets of paper could you cut that with? And it's an infinite number. So collinear means shares a line, and we have coplanar, which means it shares a plane. Okay. So, a few more concepts to get through here. We have the segment, and we have the ray, okay? This is line segment CD, and over it, you write a line segment, okay? You don't have to put the little dots, but you may on either end of it. And what that means is that the line has endpoints. We're going to learn in next week that we can actually define that by a distance. That means it's that we can measure from one endpoint to the other. There's a finite distance, okay? So that is our line segment. Versus when we have a ray, let me redo that, guys. So I have one endpoint, okay? And I have CD, but I have to write this way, okay? CD has to be written as this. CD, you're going to start with the endpoint, okay? And it is not going to be DC. That's a different thing. That means that we would start with D and then go towards C, rather than starting at C, which is an endpoint, and going towards D. I hope that makes sense to you, okay? Right, our next thing is regarding intersections, and it's going to be the last thing that we're going to discuss today, okay? So intersections. When we have lines intersect, it means that they cross each other, right? One line crossing another, and they do so at a point. Versus planes intersect each other or cross. Now I want you to think about this. You guys have seen this a lot, right? If you ever, I think a good approximation is when you see cardboard boxes, right? And you ever see dividers inside of those cardboard boxes? If you were to pull them apart, right, you could have an entirely, you'd have your own plane, but they're going to cross each other at a line. Think about this. It's a crease, right? If you had, like think about the newspaper, right? So they fold the newspaper in the middle, and that's your line. If you were to open that paper up, kind of at like a right angle, right? You'd have one big sheet that could be your plane, another big sheet be another plane, and they're gonna cross each other at that line. Okay. Let me give you guys now that we've discussed intersections. And we are actually, I think, coming up on the end of our block shortly here in about 4 minutes. But I want you guys to go ahead and consider this. Notice what I'm doing. I've drawn 4 lines, but here what I'm really actually constructing is a plane. So I just thought I'd just show you guys how you do that. You're going to make it kind of like a parallelogram, okay? Which some of you may know what that term it means. Some of you need to learn that this course. And what I'm trying to, and I'm going to just shade it in real quick, it's this area right here, right? That's going to be our plane. That's our little flat surface. And I can put an infinite number of lines within that, right? I could also put a line that doesn't exist on that plane through it. So for example, I'm going to put a line and it's going to stop right here. I could make that an endpoint, but I'm going to put like some dashes to kind of show that it's like a dart going through a dartboard, right? It's going to puncture that plane right there. I'm going to call this guy line L. Okay, it doesn't always have to be line L. I could, for example, name this thing line G. Okay, so it's a cursive line G. And then this point I could call point R, so capital R. Okay. And then when we define planes, one more thing with regard to notation, the last thing for today, is that I can use an uppercase cursive letter. So we use uppercase print letters to make points. We can use that for notation to make lines, or you can use a lowercase cursive letter for a line. And then an uppercase cursive letter is going to be what we're used to define a plane. So we have plane B. Plane B contains point R, and line G intersects it, but it is not coplanar. So line G is non-coplanar. To plane B. Goodness, my stylus is really struggling here, guys. My apologies. I'm gonna have to upgrade that right away. That's all I've got for you today, and your assignment is posted onto Canvas. Good luck.